In this video, I'm going to cover some basic concepts, particularly variables, and then I'm going to cover some of the very basic symbols that you're going to need to get programming with Lantern. They are all based on C, so if you've ever programmed in C or any language derived from C, like C#, C++, or Java, this is all going to make perfect sense to you and you will recognize this stuff immediately. But I'm not assuming that you know how to program, so I'm going to start at the very beginning with the syntax and the concepts. So one of the most fundamental concepts in programming is the idea of a variable. And a variable is just a chunk of the computer's memory that we put a label on so we can refer to it. And we can put some value in there to keep track of. And we can change the value that's in there. We can look at the value that's in there. And you can really just think of it as a shoebox. It's just a little shoebox that we can put a value in, and we can look in the shoebox and see what's there, and we can get the value out of the shoebox, or we can put a new value in the shoebox. But the thing is that the shoebox can only contain one piece of data at a time. A variable can't contain two things. So when we make a variable and we put a new value in, we clobber whatever was already there. So it's just a little, think of it as just a little box with a name on it, and we're going to put a value in it. That's all a variable is. So if we had a variable called health, and we wanted our health to be 100, we would just put the number 100 in that shoebox. Now, variables in Lantern's programming language are very simple. It's just an 8-bit system, so values of variables can only be between 0 up to and including 255. We can't have numbers bigger than 255, although if you really needed that, I could show you how to chain two of these variables together to make a 16-bit number that would go up to 65 or 65535, 65,000, 64K. But that's kind of a fringe case. So just keep in mind that variables in Lantern, they don't store text, they can't store objects, they're very simple. It's just one byte of memory, one little tiny shoebox of memory that can hold a value between 0 and up to and including 255. Right? So if our health is 100, then we've just got some little piece of memory and we've put the label health on there and we've stuck the number 100 into it. So that's all a variable is. It's just a little shoebox with a label that in Lantern stores a number between 0 and 255. Now you may think it's not much of a range of numbers, but it turns out that's not really a limitation for the games we're going to be making. It doesn't seem to cause any problems at all. All right, so what kind of things do we use variables for? Those numbers can represent anything. Typically, we use them to store whether something has happened yet, like has the player, pulled the rope, or has the player found the gold. We can use that to determine if the game is over, maybe, or should the player get points for that task. We can use them for timers, for counting up and counting down. So, you light a torch and it's going to burn for 50 turns and then it's going to burn out, or a battery might burn down, or, the guard is getting angrier and angrier, or something like that, or the reactor is overheating and when it reaches critical, after 10 turns, the reactor is going to explode. So we can use them for countdown, count up timers to keep track of resources, like a battery burning down, which is kind of a countdown timer too. Storing the health of an NPC. Variables can kind of store anything that our game needs as long as we can represent it as a number. So that's why it's hard to have things like, when the princess falls in love with me, or the handsome prince falls in love with me, or whatever, right? That's hard to turn into numbers. But like, have I chopped the head off the troll? Well, that's a yes or a no. That's a 1 or a 0. So if you can turn it into numbers, you can do it in your game. There are many built-in variables, or a few. These are the ones that are commonly used: score, moves, health, turns without light, and game over. Those are all kind of self-explanatory. The game doesn't really do much with score or health. They're just there for you to use. Same thing with game over. And you can use that to, like, when the player meets all the goals of your game, you can set that to 1, and then print out the victory message, and then you can, and if the game wins, and then the next turn you can check to see, hey, wait, if the game isn't over, then I need to print out the victory message. Really, it's there so you just don't keep winning the game over and over and over and over again. Turns without light, that's how long the player has not been able to see, and that's useful for killing the player if they're, underground too long without a torch or something like that. So those are some variables that are just built in. So it's up to you to do something with score and health. If you want to. Moves every turn, it goes up by 1. Turns without light is that gets calculated automatically. What else? What else have we got? Variable names. No spaces in variable names, and they can't start with a number. I would make your variable names very descriptive. So dragon _ angry. Is the dragon angry? Gold _ found. Have I found the gold? Right? Those are very descriptive variable names. G, not a good variable name. D, not a good variable name, because I look at the code and I don't know what that is. And you won't know either when you come back and look at your own code 6 months later. So give your variable names that indicate their purpose in your adventure, and that will make just figuring out your code a whole lot easier. That this is how I typically name my variables. If you want to name them, you don't want to put underscores and use like Java style variable names where you don't have the underscores and every word starts with a leading capital. That's fine too. But the thing is, just variable names can't contain spaces. They can't start with a number, and they should be descriptive. They should tell you, you should look at that variable and know what the value in it means for your game. All right. Let's move on to some basic symbols, and then we'll start putting this together into some statements and into some code. So basic statements. The double slash. The double slash just means everything after it is a note. It's a comment. It is just a way for you to leave notes in your code explaining what your code does, what you maybe, something you need to finish, something that you were trying to figure out. This is very common. Good programmers put lots of comments in their code. When you get to college, professors will mark you down if you don't put comments in your code, because they have to look at your code and try to figure out what it does. And the fastest way to do that is if the code contains comments that say what it's supposed to be doing. So double slash means stop, like this. Everything after the double slash is just a message in the code for you, the programmer, to help you understand the code better. It's not something the computer is going to try to execute. So in my code, you will see stuff like this a lot. Notice the double slash followed by finish this code later. Right? This means, hey, I'm leaving a note in my code to tell me to finish this thing later. So double slash followed by anything is just a note. The double slash means ignore everything after me. All right, what else? Stuff that's very simple. The semicolon, or maybe half of a winky face in Wheat speak, or no, not Wheat speak, texty emojis, yes. So the semicolon is used to end a statement. Think of like in English when you're typing, or Spanish when you're typing, and you get to the end of a sentence, you hit the period. That's exactly what we do in programming, except it's the semicolon. The semicolon means end of statement. It's what the syntax analyzer uses to break up multiple statements. So you can have multiple statements on a line as long as they are separated by semicolons. Typically, you don't do that. Usually one statement per line. So after every statement, you have to have a semicolon. All right, what else have we got? The equal sign. Equals means a sign or set. And equals it's not quite as simple as you might think. And you might say, I see that in math all the time. Well, in computers, it means maybe something a little bit different from what it means in math. So the equal sign, the single equal sign, is used to assign a value to something. It really means copy the value on the right side of the equal sign and put it into the thing on the left side of the equal sign. it's really it's a store operator, or a load operation. It's a move. It's taking data from one place and moving it somewhere else. It's evaluating the right side of the equals and putting it into the value on the left. So let's look at an example here. Health equals 100 semicolon. Remember, the equal sign means evaluate the thing on the right, figure out what that is, and put it in the thing on the left. So this statement, health equals 100 semicolon, means take the number 100 and put it into the variable called health. So remember, health is a shoebox. It's a little variable, a cell of memory, and it can contain one value. And we're saying, hey, take the number 100 and put it in that little shoebox called health. So after we do this operation, health will be 100. If health was 0 before, we just clobbered whatever was in that shoebox and we replaced it with 100. But this means take the thing on the right and put it in the thing on the left. So what we're doing here is taking that value on the right and we're putting it in the memory location on the left. All right, so remember, that thing is a shoebox. We're taking the number 100, put it in the shoebox. Take the thing on the right, put it in the thing on the left. All right. Now, what else? What else could we do? Well, this example here, just sets a value to, or a variable to, a particular value. What if we wanted to change a value? And just, this thing doesn't have to be the number 100. It could be another variable. We could set, we could say health equals score. I mean, that wouldn't make a lot of sense, but we could take the score and put it into the health. This could be a complicated expression, and we could put it in, we evaluate it and put the result in health. All right, now, in this example, what we're doing is we're putting a value, a constant, into health. We're just saying, you're 100 now. But what if we wanted to change health? Like, what if we wanted to subtract 1 from it or add 10 to it? How do we change a variable? Right, so examples would be, decreasing the score or increasing the score. Increasing the score because we did something, decreasing health because, we walked across the hot lava without our shoes on or something. I don't know. We walked through the cave and a rock fell on us. So how could we change a variable? Well, we can use our equal sign for that. Our equal sign will work just fine, right? Because what that means is take the thing on the right and assign it, put it in the thing on the left. So let's look at this statement right here. Health equals health minus 1. So remember, these things are evaluated from right to left. So first we're going to evaluate the right side. And once we know what that is, we're going to put it in that memory location on the left. So to compute health minus 1, we're going to say, okay, well, what's the value of health? And we're going to pull health out of the shoebox. So we're going to look in the shoebox and say, okay, well, maybe health is 100. Okay, great. So now that we have 100, we'll subtract 1 from it. 100 minus 1. So what's that going to be? Well, that's going to be 99. And once we've computed the right side, we're going to put it into the variable or the target on the left. So we're going to take health out of the box, look at it, subtract 1 from it, and put it back in the box. So that's what that means, right? So we're going to take health out of the box, subtract 1 from it, and compute that result, and then put that back in the box. So at the end of this, health has now been changed. We've taken the value out, subtracted 1 from it, and then put it back in the box. And it doesn't matter what health started out as. If health was 100, we pull it out, subtract 1 from it. Now it's 99. Put it back in the box. Then the next turn, we do the same thing, maybe. Okay, what's health? Well, now it's 99. Subtract 1 from it. Okay, what's the result? 98. Put 98 back in the box. So this is a way of changing a variable. First, we get the variable out of the box, do something to it, and then put it back in the box. What if we wanted to add 10 to score? It would be the exact same thing, right? Same syntax, right? Okay, pull score out of the box, add 10 to it, and then Now that we've computed that right side, assign it back to score. Compute the right side and assign it, put it in that target value on the left. If you've programmed in Java or C# or C++ or something, Lantern does support this syntax. This is a shorthand for what you just saw. Health minus equals 1 is the same. It's a shorthand of health equals health minus 1. Score plus equals 10 is a shorthand for score equals score plus 10. So if you're familiar with these, go ahead and use them. Lantern supports them. If you're like, that's a bit much for me, then you can use the long form like that. Score equals score plus 10. That's the same thing as this right here. They mean exactly the same thing. This just expands to this, when the code is analyzed. Okay, what else have we got? So we have our equal sign, we have minus equals and plus equals. Lantern also supports plus plus and minus minus. These are used to subtract 1 from something or add 1 to something. This is something you do a lot in programs. So health minus minus means subtract 1 from health. This is a short form. It's another short form of health equals health minus 1. And score plus plus is just a short form for score equals score plus 1. So minus minus after a variable will add 1, or we'll subtract 1 from it. Plus plus after a variable name will add 1 to it. So if you've heard of C++, that's a joke, right? That language name is a joke because plus plus means add 1 to. So there was a language called C, and then someone, well, what's the next thing after C? Well, that's C++. It's add 1 to C, right? So that language is actually kind of a computer science joke. All right, so that's working with variables. Now, there's one other very important operator that we're going to look at here, and that is how to go into an object, like because remember in Lantern, everything has got all these properties. Everything's an object. A room is an object. An object is an object. And we have flags like, is it portable? Can I put things in it? Can I put things on it? Can I wear it? Is it opened? Is it locked? Is it lit? So how do we test those, or how do we change those? Testing those we'll get to later. So how do I go in and I test the player's location, or the torch's lit property, or the door's open property? How do I set the torch to be on, or the door to be open, or the player to be somewhere else, or the treasure chest to be unlocked? How do I do that? How do I go into an object and change one of those predefined properties that Lantern puts on things? Well, we use the dot operator. It's just the period on the keyboard. So the dot operator is the apostrophe S, and it works like this. So the dot operator is the apostrophe S. When you see the dot after an object's name, think apostrophe S. The syntax is object dot property or attribute name. So, and we'll look at some examples here. So it's object dot something, and that something is going to be one of those properties that Lantern builds into everything. So let's take a look. Player dot location equals cave. So player dot location is an attribute. It's the number of the room that the player's in. So what this would do is it would say, okay, hang on, cave. Well, that's room 10 in the game, or object 10 in the game. So take the 10 and put it into the player's location. Remember these equal signs, it takes the thing on the right and it puts it into the memory location on the left. And there's our dot, that's the apostrophe S. The player's location is now the cave. Or take the cave and copy it into the player's location. The wizard's location is off screen, like semicolon, end of statement. So, or take off screen, which is object 0 in the object tree, and copy that into the wizard's location. The wizard's location is now off screen. You could read it that way, or you could go right to left. Take off screen and copy it into the wizard's location. Torch.lit equals 1, semicolon. So those properties, like all the little check boxes that we'll see, is something open, close, lock, portable, scenery. those are the little check boxes that you'll see in Lantern. Those are either 1 or 0. If it's checked, it's 1. If it's not checked, it's a 0. So if something is lit or is emitting light, its lit property is set to 1. So we're going to say the torch's lit property is now 1, semicolon. That's how you could read that. Or take the value 1 and stick it into the torch's lit property. Steel door.locked equals 0. The steel door's locked property is now 0. End of statement. That's how you read this stuff. All right. And then another thing we're going to look at real fast, and then that's kind of it, is just some other stuff that we're going to use all the time. Just how do you print a message? There's a command called print line. If you just type PR and hit tab twice, Lantern will stub that out for you. The message that you print out goes in double quotation marks, and you cannot do stuff like you can't put multiple strings together with the plus sign. It can only kind of print out one thing. So if you need to print out, your score is now 10, you'd have to print out your score is now, and then print out the variable 10 in a separate statement. So, but to print a message, you just say print line and then the text that you want to print in the double quotation marks. So in your game, if you want to have like quotation marks around something somebody says, use single quotation marks because the double quotation marks indicate that this is the start of some text and the end of some text. So this will print it out and then follow it with a new line. It'll kind of drop down to the next line. So if you want to print out some text and not have the new line, like you want to print a whole bunch of stuff out on the same line, then you can just use print. And again, it's just the text that you want to print out in quotation marks. All right, so we're going to just use those in some quick examples. Here's just those basic symbols again. We've got the double slash, the equals, the semicolon, and the dot. And then I guess we could also throw like, plus plus and minus minus in here too. Plus plus, minus minus, not minus minus minus, subtract 1 from. We're making the slides in real time. All right, so plus is add 1 to. There we go. All right, there you go. So plus is add 1 to something, minus minus is subtract 1 from something. So we covered those. And let's now that we've got that, let me pop over to Lantern and do a quick demo here. All right, so dog is snoring. Okay, that's awesome. All right, so let's go into Lantern. Can I shrink this a little bit here? And okay, that's close enough. So here we are in Lantern, and what I'm going to do is just make a little simple test project here. File, save as, demo, save. All right, so I should just be able to run this, and it'll pop up here. There's my little test window. So I'm in room 1. This is the end of a dirt road. So that's the little starter code that it gives me if I don't, import a map. But what I want to do here, let's go to variables. And you can see here that we've got a bunch of variables built in for us already. I'm not going to touch on some of the other ones here, but what we've got here's our health. We've got a variable called health, and notice its initial value is 100. And we've got score. Its value is 0. So let's just run our game here. I'm going to launch the little player, and if I type the word vars, Lantern will actually dump out all its internal variables, including any variables that we have added. So you can see here that moves is 0, and if I type wait, and I type vars again, you can see that moves is now 3. So I can use that to kind of keep track of stuff. All right, and you can see health is set to 100. What I'm going to do here is make an event. And now events run after every command. So I'm going to say like, I don't know. I'm gonna make maybe. Oh God, dog's having a nightmare. Restore health. Okay, I don't know if you can hear that. It's all right. Poor dog. Okay, there you go. So I'm gonna make an event called Restore Health. And what I'm gonna do is I'm gonna say health plus plus semicolon. So what that does is it's going to add 1 to health. Actually, let me longhand it out. Health equals health plus 1. All right, so what that's going to do now is that every turn it's going to add 1 to health. Now, so let's I'm going to go back to now I'm going to go over to functions here, and you'll see I've got a function called game start. This is where I can put stuff that's going to run right before the user has a chance to type commands. You can put in welcome messages here or randomize the location of objects. What I'm going to do is set health to 50. And you can see there's a comment right there that explains what this function's for. Now I'm going to save this, and I'm going to launch the player. And so if I type vars now, whoops, you can see health is 50. Why is it 50? Because we set it to 50 in the game start function. All right, now remember, every time I enter a command, the events are going to run. So what happens when the event runs? It's going to add 1 to health. Health equals health plus 1. So now if I run this, and I type vars, whoops, you can see that health is 50. Now if I type wait, and I type vars again, notice my health is now 53, right? Because every time I run a command, it runs that event, which adds 1 to my health. So there's an example of how you can manipulate your variables. Why don't I, just for fun here, let me do score minus minus. And then in my game start function, where was my functions over here, I'm going to say score equals 100. And let me save that and run it. And now if I type vars, you can see, so score is 100, health is 50. Let me wait here. Whoops, wait. And what do I got? So now you can see score is 99 and health is 51. So every time I enter a command, I'm running this event here called restore health, and it's just monkeying with these variables. Also, just to show you some stuff that, remember that print line, PR, tab, it just expands to print line, changing variables. There you go. So now if I run this, see how it's printing out changing variables? So you can see that that event is actually running every time I execute a move here. And then also, Lantern's kind of squished, but you can actually, if you go down, if you actually have like the full interface here, you can see at the very bottom of Lantern, I've listed out all of the different functions that you have. We have print variable or print var. We can actually print out our variables. So let me do something like, print health is now space and semicolon. Okay, so now that's going to print out health is now PV tab expanded to print var. I'm going to put health. All right, and then finally, I'm just going to print out a blank line. Let's print line. So I'm going to print health is now without a carriage return. Now I'm going to print out the value of health, and then I'm going to print out a new line. So watch what happens now when I run this. Test run. Health is now 51. Health is now 52. Health is now 53. Health is now 54. Health is now 55. Right. So, so there you go. There's a pretty cool little demo of how you can start using the syntax right away, and also a good demo there of events. So events are code that execute after the user has successfully entered a command, and those can be used to do things like check the state of your world. Has the player won? Compute the player's score? Is it turn 50? Does what happens on turn 50? Does the reactor explode? Is the game over because the player hasn't solved the game in time? That's where all this stuff can be done. Or if the player's here, move an NPC over there. So there we go. Oh wait, right, we didn't cover the dot operator, I guess, but we'll be seeing more of that in a bit. Well, let me I'll do one quick little thing here. I'm going to make a variable. I'm going to make a variable called location. I'm going to make my own variable. I'm going to call it location, and so now I have my own variable, and let's go to events here. And what I'm going to do is I'm going to set location is equal to the player's location, right? So pl tab dot l tab. All right, so what this is take the player's location and put it into this variable. And now I'm going to print out that variable, pv tab, nope, pr tab. What do I want? I want this. There you go. The player is in room, and I want to print out location. I don't think Lantern supports, like, I don't think I could say print out player dot location. Maybe that would work. I don't know. I guess I could try it. Save it, run it, and the player is in room 2. Okay, so let's check that out. What does that mean? Let's go to our objects here, and you can see off screen is 0, player is object 1, and room 1 is room 2. So that's how that works. I can test, hey, is the player here, or is the player there, right? Or I can change the player's location. I can move the player somewhere else. So there you go. There's making your own variables, printing stuff out, using events. We'll do more with this.